Open your book to page 33. Page 33 has a list of important facts that is important to know. So let's go through some of them. So let's go to number one. Number one says that it says the diagonals of the rectangle have the same length and bisect each other. Okay, so you have a rectangle and you have the diagonal. So what it's saying is that the diagonals of the rectangle, they have the same length and they bisect each other. So you end up with congruent length on each one of that. So again, the length are congruent and they bisect each other. Therefore, bisect means cut in half, right? And therefore, all these would be congruent to each other. Okay, let's go to number two. It says if the diagonal of the parallelograms are equal length, the figure is a rectangle. So let's say if you have a parallelogram. So parallelogram, okay, if you notice in this case, the diagonals are not equal. The length, see the lengths are not equal. The only time they are going to be equal is when you have a special parallelogram, which is a rectangle. So a rectangle is a special parallelogram. Okay? So again, so if the diagonals are equal, so they're kind of the converse of each other. So if the diagonals are the same length, then it must be a rectangle. Okay? So again, so only time that you're going to have equal length diagonal is when it's a rectangle. So they are kind of the converse, okay? The opposite of each other. Okay, number three, it says the diagonal of a square are perpendicular to each other. So when you have a square, and when you draw the diagonals are perpendicular to each other. Okay, so again, when you have a square, when you draw diagonals, they are perpendicular to each other. Okay, so number four. Number four, it says the segment that join the midpoints of the consecutive side of a square form a square of one half the area of the original figure. So let's say if you have a square, and you join the midpoint of the consecutive side, means you go from one to the next to the next. Okay, it means you don't go across. Okay, so you connect the midpoint. So again, if you have a square and you connect the midpoint of the consecutive side, you're going to end up with a smaller square with area half of that. And it's very easy to see that the area is half, because if you just kind of cut into triangles, see the original square has 8 triangles, and then the smaller square has only 4 triangles. So the smaller square is half of the original big square. Okay, let's go to number 5. Okay, number 5. It says if the diagonal of the rectangle are perpendicular to each other, then the figure is a square. So again, if you look over here, notice the diagonal are not perpendicular, right? So the only time the diagonals are perpendicular is when you move this closer, it becomes like this, right? And so therefore, if the diagonals of the rectangles are perpendicular, then it must be a square. So a square is a special rectangle, and a rectangle is a special parallelogram. Okay? So again, that's number 5. Number 5 is when you have a rectangle that the diagonals are perpendicular, then it must be a square. Number 6, the diagonal of a rhombus are perpendicular. Okay, so if you have a rhombus, Okay, so you have a rhombus, and then if you draw the diagonals of the rhombus are perpendicular. Okay, number 7. It says the segment that joins the midpoint of a consecutive side of a plane quadrilateral forms a parallelogram. Okay, so quadrilateral means 4-sided. So if you just go ahead and draw any 4-sided. Okay, so you have quadrilateral. Then you're going to connect the midpoint. I'm trying to be exact, try to be accurate. Okay, so now you connect the midpoint of the consecutive side. So you can see it's going to, so you connect the midpoint of the quadrilateral, you're going to end up with a parallelogram. Okay, okay, number 8. Okay, number 8, I'm going to use this one. So number 8. Number 8 says the segment that join the midpoint of the consecutive side of the rhombus form a rectangle. So for number 8, I'm going to join the midpoint. Okay. Again, I'm trying to be accurate. Okay. So here you're going to join the midpoint. Okay. And you end up with a rectangle. And notice the comparison between the two. See, what happens is this is just kind of any quadrilateral, you're going to end up with a parallelogram. Now this is a spatial quadrilateral, right? The rhombus is a spatial quadrilateral, and therefore when you connect the consecutive side, you're going to end up with a spatial parallelogram. Okay? And therefore you can see it's more regular, right? So this is just a parallelogram, and this is a rectangle. Okay. So again, those are just important facts that kind of is important to know as you do some of the problems later on.